Hello, game developers, and welcome to yet another exciting episode of Game On. I am Todd Kerpelman. I'm a developer advocate here on the Google Play Games team. And here with me today is Wolf Dobson, developer programs engineer, also on the Play Games team. And he is here to talk about one of my most favorite things in the whole wide world, and that is physics engines. So Wolf, why don't you take it away?
All right, so today we're going to talk about Liquid Fun. This is our brand new open source physics engine that we've just released cross-platform in C++.
Very exciting.
Mm-hmm. So first thing we should talk about is where do you get it? And our producers here have added a link that you can click on that'll take you straight to our GitHub page. And in this little chat here, we're going to do an overview, we're going to do some demos, and we'll even talk about a little code. So first, let's talk about physics engines.
What's a physics engine, Wolf?
It's your favorite thing in the world.
Oh, that's right.
So a physics engine is the mathematical simulation that helps you create procedural animations filled with physical bodies. So in a game, you're simulating per frame, and the system divides times into little slices and updates on all the objects, each frame, based on their positions and velocities. So if there are conflicts like collisions, then the system resolves those safely. The most basic physics simulation you can think of is actually Pong, the single body that's moving around, bouncing off against two paddles.
I guess that's true.
This is obviously a little bit more complicated. Liquid Fun that we're providing is just a numerical simulation. We have a little simple visualization, but in your game, you're going to want to add art, and sound, and story, and all the rest of that stuff. So this is just the mathematical part.
So like in a model view controller kind of analogy, this would be the model. This is telling me where everything is in my game, but it would be up to my game to actually take that information and turn that into something on screen that I would present to my player.
Exactly.
All right.
So this is a superset of Box2D. Box2D, I'm sure you've heard of.
Box2D, yes. It's a very popular 2D physics engine developed by Aaron Cotto, I believe, and it's used in like just about any game out there that uses physics. I know Angry Birds uses it.
Anything with 2D physics has Box2D
There's a pretty good chance that it's using Box2D.
If your game uses Box2D, you should be able to drop this engine in and it'll just work. So just as a view, this is our typical piston demo here. That shows just rigid bodies interacting with each other.
And I mean, this is demonstrating a lot of interesting things, right? It's sort of demonstrating, like, well, first gravity and also momentum, and I guess you would see like angular momentum if that
and joints too on the thing and motors turning the thing. But this is all very standard Box2D stuff. The sort of special sauce we're adding with Liquid Fun is obviously particles.
Ooh.
Yes. So let's look at some particle demos. This is a whole bunch of particles and a giant rigid body slamming into all those particles.
Wow.
Yeah, it's a lot of particles. There are thousands and thousands of particles running around inside there. And this is an active simulation. So if I grab hold of this, I can kind of swim through this and push these guys out of the way. I can touch groups of particles and throw them around. It's pretty cool.
Yeah, because normally when I think of particles, I think of them used for like sort of visual only effects like fire and smoke. But I guess what you're saying is particles could also be used for generating things that look like water.
Yeah, exactly. And these particles are actually, and these particles can interact with the entire rest of your physical system. And this is your typical wave machine. You can actually see kind of wave physics going back and forth as it swims around.
Gotcha. And so, I mean, basically, this engine is simulating each of these thousands of particles individually, and sort of by grouping all of these behaviors together, you get something that suddenly creates waves.
Yeah, it looks like water. It's pretty neat.
Yeah, that's cool.
So, as I mentioned before, the engine is cross-platform. It's written in C++, and we've provided builds out of the box for Android NDK, obviously. We also have Linux, OS X, Windows, and people can feel free to contribute to whatever other platforms they want to add.
Gotcha. So there's a pretty good chance I could add this to any mobile game I wanted. All right.
So this is kind of way out of scope, but we'll talk a little bit about how physics engines work. So in physics engine, you basically create a world. You add some rigid bodies to it. So here, a circle and a triangle. You might add some joints to connect them. And then you step the simulation forward. And in this case, since there's nothing supporting those guys, they're just gonna fall. But again, the secret sauce with Liquid Fun is that we're adding very large numbers of particles that can interact with these rigid bodies.
Okay, so what makes a particle different than a rigid body?
So particles are the smallest unit of matter that can interact with things. They act like rigid bodies, but they don't have rotation, so we consider them uniform circles. And they are sort of packed intelligently in the system so they can be rendered and simulated very quickly.
Okay.
Rigid bodies basically are going to be slow and expensive, and particles are small and cheap.
Okay, so by basically placing a few limitations on these things, the engine is then able to render hundreds or thousands of them at once.
Thousands, definitely.
Okay.
So particles come with basic physical characteristics like color, size, position, velocity. Color is for your reference when you're rendering them. It doesn't actually have any effect on the numerical simulation.
Gotcha, but I can ping the model and say, hey, what's this
What
unit's
color is this? And then also strength. So if you have particles that are sort of stuck together, like viscous particles, you can say how strong you want that viscosity to be.
Okay.
No, and as noted, there's no rotation for particles. So if you rendered them as little like top hats, the top hats would always be facing up, even though thousands of them are smacking against each other.
Gotcha. So as a general rule, you probably don't want to render them as something that where you would notice it doesn't rotate.
Yeah, exactly.
In fact, most likely I might kind of apply some sort of filter to kind of not show the individual particles, but kind of group them together. So I might see a big wave or something.
No, actually, in these simulations, we're just sort of rendering a Gaussian spot. And as lots of them are, as they sort of, the spot is a little bit bigger than the body, and as they kind of overlap each other, you get the sort of areas that look kind of solid.
Okay.
So here's the code for creating a particle. If you used Box2D before, this should seem really familiar. You create a particle def, you can set some flags on it, and you can also set its position and its velocity, but not its rotation. Okay. And then you tell the world, I'd like to create a particle using this definition.
What does elastic particle there mean?
So elastic particles are springy particles. They're particles that are connected together like a jelly. We'll see one in just a minute.
All right.
We'll see a lot of elastic particles in just a minute. Particle group is created by instancing sets of particles together in a different in a shape. There are ways for you to create and destroy lots of particles at the same time. So you can set all the regular properties like velocity and position, but you can also add the rotational angle if you have one of these jellies. You can also set, you can rotate the shape, and then you can set the rotational velocity as well if you have one of these jellies.
Gotcha. So particles don't have rotation, but a particle group does have a rotation.
If it's an elastic one, yeah.
Okay. I think you're gonna need to show me a demo.
I think we're gonna show a demo.
All right.
So creating particle groups is, again, should feel pretty familiar to Box2D people. You create a shape, you create a particle group definition object, and then you instance the group with that. So
what does the shape here mean?
A shape is a Box2D primitive, so it's going to be like a polygon. So you can make a circle, you can make a giant square, you can make an L shape, you can do whatever you want.
And is the idea these particles have to fit into that shape?
It will create particles with the density in the shape that you specify.
Okay. I'm a little confused. Maybe we can go through this code and let me know what you mean.
Right. So you can see here we have the particle group definition and a shape. The shape is just a box. And then on the particle group definition, we're saying, look at this shape. We're setting some flags on it. Its initial angle, its initial angular velocity, and that's the angle of the entire shape that we're setting. And then we're instancing 5 groups of these all at once.
So you're creating 5 groups of
square-shaped particles.
But then within these, do you need to then create the particles that are attached to these shapes?
No, when you say create particle group, you instance all these particles at the same time.
Okay, and so that's where the shape definition comes in. It's creating these groups of particles that essentially fill this shape.
Yeah.
Gotcha. And the density of particles within that shape, is that something that I would specify, or?
Yeah, you can set the particle size.
Okay. So I don't need to have like 4 nested for loops that create all these thousands of particles.
You just make a shape and it will fill it with particles.
Well, that makes a whole lot more sense. All right.
So if you want to destroy particles as a group, it's pretty easy. This code example here walks the entire list of the entire list of groups in the world and just destroys all of them. This would be like a simulation shutdown step. The particles in the groups can interact with each other, but then you can kill the groups en masse.
So let's say I have two groups here, and I mix them all together, and they form this, giant mess.
Yeah.
I can then say kill group A, and like half my water will suddenly disappear.
Exactly.
Huh. So I guess you got to be careful about using that to make sure that that's actually the side effect that you want.
Exactly.
Okay.
Once you start pouring liquids together, they become intermeshed.
Yes.
Particles have a lot of different behaviors. By default, they operate as a simple liquid, but you can add these new particles like elasticity with flags. So let's show some demos here.
Okay.
So first, I'm going to show you a set of particles that are elastic. So here you can see they're kind of acting like jelly. And if I grab any small collection of particles and move them, the whole body moves at the same time.
Gotcha. And I can see they're trying to keep sort of their original shape.
But they can still be deformed. If I drop objects on them, then
Gotcha.
they're gonna sort of deform to accept that.
And so these were created by particle groups.
Mm-hmm. Yeah,
One has a shape that's a circle, the other has a shape that's a rectangle. You've given them elasticity,
Right.
which means that they are springy and they cannot be broken apart.
Right.
Okay. So that would be useful for like if I wanted to create bouncy balls or just fun-looking jelly types of things.
Like
but somehow,
this
yes.
is such a cool jelly.
And somehow it's important for my game to make sure that this is still one solid object. It doesn't get broken apart.
Right.
Okay.
So here's an example of particles that can color mix. So this is a regular fluid, but as the particles brush against each other, it averages their color as they rub. So you can see the red and green turned into this yellow on the left. And if I kind of mix these, whoops, I kind of spilled. If I mix these, I can kind of bring the green into the blue and get kind of a uniform light blue.
Gotcha. And so these colors basically mix just based on when they touch.
Yeah.
So I could, like, let's say as a developer, I could use this if I wanted to, like, measure like some hot water and some cold water or something, and like,
Yeah, you can
I
put
would
it
just
together.
sort of ping the color as sort of a way to represent how hot or cold these things are.
Sure.
Okay. And so I've noticed these break apart very easily. So these are not elastic particles.
No, these are regular fluids.
Okay.
And lastly, here are some viscous fluids flowing through a maze. And then we have a couple of little pumps that are kind of moving it back and forth. And you can see I'm getting this sort of blob down here in the lower left. And also, if you look up at the right, you can see I'm applying a constant force to this pump, and it can't compress this viscous fluid enough, so it kind of bounces off of it.
Sort of like real water, I guess.
Exactly.
Right.
And then down near the bottom, oh, there it fell by itself. I can use this to sort of pump water uphill. And knock this other rigid body into the drain.
And so by saying these are viscous, what you're basically saying is like these have some amount of surface tension.
Yeah,
So this probably
they
gives
want to
me-
stick together.
This gives me more realistic looking water than if they were not. Like it would probably look like sand if you did not have this viscosity turned on.
Yeah, they would look. It would look more. It wouldn't cohere as much. You wouldn't end up with as many of these sort of big blobs.
Gotcha. And the more and more viscous, kind of the more
Yeah,
and
and
more you go from
you
water
can-
to like toothpaste or something.
Yeah, exactly.
All right. Maybe
And
maple syrup. I'm trying to think of fluids with high
slime,
viscosity. Yes.
something like that.
Okay.
And we have more particle behaviors besides even these, like powder and tensile and wall and things like that.
What do those mean? What
Well-
does powder mean?
So powder would be something like smoke. It would be things, it doesn't stick to walls very well, and it doesn't want to stick to itself very much at all. So it's powder. You can read more about all of these in the user manual that we have. And speaking of our user manual, come on by to our GitHub page, join us. We have a discussion group, and we have a programmer's manual, and we have an API reference, and we have all the source. So,
Cool. So what's the license on this? You said it's open source?
it's open source. You can pull it into your game right now and publish it, and that would be great.
Awesome. Well, that sounds like a very useful thing. Why are we giving this to the world, Wolf?
Because we want to make games better.
Oh, well, that's a good idea.
We want to make people's games awesome.
All right, well, this seems like a good start. As someone who is a big fan of physics games, I encourage you all to take a look at this and start adding crazy looking jelly things to your game. There's probably a whole world of like water and jelly games that we just
There's a
haven't
genre of jelly games.
just waiting to be discovered. And so maybe that will be you. Yeah, seriously, check it out. I think Physics Engine I always just find really interesting because it's like a very complicated system where you can have a lot of kind of rich behavior and create a lot of really interesting, rich puzzles. But at the same time, like, you know, a 3-year-old intuitively understands how everything in the world is going to react.
Well,
and
it's
so
really,
I think it makes for really good game design. I think why there's so many good physics-based game designs out there.
It's really a sandbox for emergent gameplay.
Mm-hmm.
Like unexpected things happen when you put physics together, and that makes it surprising and fun.
Or you could, you know, really just kind of make this wave machine, and I'd watch that for several hours.
Yeah, you get hooked just looking at these things.
So you said OS X. Can I make a screensaver using this stuff?
If you want to.
Awesome. All right. Well, I know what I'm doing over the winter break. All right. Well, thank you everyone for joining us. Take a look at what we've got on our GitHub page. I think it'll be pretty interesting. And we will see you all in a week or two.
Bye.